Hey, Algebra 2A people, Mr. Hayward here. We left off last week on number 15 for our SAT practice that we're doing. Today we're going to be going through 16 through 23, so that's the next 8 problems. Then on Wednesday we will do the last 7. All right, let's kick into it. Now, right off the bat, when I'm looking at number 16, it's got a bunch of stuff. So SAT's automatically testing on whether or not you're actually going to read this. This is, are you taking the SAT seriously? If you're not taking the SAT seriously, you're going to see all this garbage. You're probably just going to guess. And guess what? All this garbage actually relates to the next 2 questions, 16 and 17. So if you're just guessing, you have now gotten a 25% chance of guessing each of those correctly. So the chances of you guessing both of them correctly is actually 1 out of 16, which is very low. Anyways, so I'm going to look at this. It says that he's building a concrete patio in his backyard, and he's got 3 different places to buy materials and to rent costs. I was looking at this. I don't know why anybody would rent a wheelbarrow, but whatever. I don't know much about concrete patioing, so I don't know, whatever. So it gives you the materials cost, the cost to rent a wheelbarrow, and then the cost to rent a concrete mixer. Then it goes even further, and it gives you a formula. You can pretty much right off the bat say, if it gives you a formula, that's probably important, okay? Y equals m plus w plus k times x. You know, even if you don't fully understand what that formula is, you should be able to use it to answer this question. For what number of days x will the total cost of buying the materials and renting the tools from store B be less than or equal to, I'm going to highlight that, less than or equal to the total cost of buying materials, renting tools from store A. So basically, you're trying to figure out when is B less than or equal to A. Okay. Then it gave us this formula. The formula says that the Y, which is the cost, it says Y equals M plus W plus KX. Now, you have to figure out what this is like for B and what this is like for A. Now, it gives you letters. You're trying to solve for X here, so you've got to plug in letters for M, W, and K. You go back up here, it gives you numbers for M, W, and K. All right, so now I am going to start off with store B here. So for B, it looks like M is 600, W is 25, K is 80. I'm just going to plug them in. 600, 25, 80, and then we're trying to solve for X. Let's just simplify that really quick. That's 600 plus 105X. Okay, so that's store B. Now I'm going to do the exact same thing for A. Okay, and I'm going to look at my numbers for A. Go back, 750, 15, 65. Okay, so 750, 15, 65, right? Simplify that really quick. 750 plus, what is that, 80x? Beautiful. Okay, now I'm going to come back up here. This said less than or equal to, and that sets up a quick and simple problem that we can solve. This is an inequality. The setup is the sucky part. Once you get here, this is simple algebra, okay? At this point, I would subtract 80x from both sides, and I would get that 600 plus, what is that, 25x is less than or equal to 750. Then I would subtract 600 from both sides, and I get that 25x is less than or equal to 150. And then when I divide by 25, I get x is less than or equal to 6. Okay, notice that algebra, once I got to this part, the algebra took no time at all. It's the setup that sucked. So I had to look at everything I was given, use a formula, but then also look at keywords here. This is one of those problems that's going to take more than the average amount of time. Some problems are going to be pretty quick, might take you 5 seconds. Some problems like this might take you 5 minutes. Okay? Don't forget, if you're ever freaking out over a problem and you're sitting here and you're about 5 minutes in and you still have no idea what you're doing, skip it, move on, come back to it later. Anyways, we got the answer of x is less than or equal to 6. Now be very careful. Notice they wrote x is less than or equal to 6 and x is greater than or equal to 6. Don't in a rush put in the wrong answer even after you did all of that work. Okay. All right, now we're going to move on to number 17. Now remember, 17 is talking about the same data set there. So if, not data set, yeah, data set, table, whatever. If the relationship between the total cost, y, of buying the materials and renting the tools at store C and the number of days x for which the tools are rented and graphed in the xy plane, what does the slope of the line represent? Okay, wow. Graph, just for fun. Got a line, okay? Relationship between cost is here of buying materials and renting the tools at store C, and then the number of days. Number of days. Sorry, you can't see that. Here. Okay, so I've got a line. Obviously, as number of days goes up, the cost goes up, right? Because he's renting things. So every day that he rents something, he's going to be paying more. So you're going to have a simple line like that. If it helps you to draw a picture, awesome. Now, what you're trying to figure out is the slope, the rise over run. What does that represent? Okay, the total cost of the project, the total cost of the materials, the total daily cost of the project, or the total daily rental cost of the tools. Now, I want you to think. Slope is supposed to represent a rate of change. So in this case, the slope is how much it is changing every single day. Okay. Now, the only cost that's changing every single day is that you're continually renting tools. So that means that the only thing that's changing is the cost of the tools. At the very beginning, you would have bought all of the materials, and so that means that the answer would be here. I actually really don't like this question because I could understand somebody arguing that the answer is C, the total daily cost of the project, depending if they're buying their materials every single day or not. But either way, it's the answer. All right, let's look at number 18. Again, we've been doing problems here that have a lot of words. Don't freak out, just read them. So Jim has identical drinking glasses, each in the shape of a right circular cylinder. Hey, shoot, we haven't done anything in my class about circular cylinders. That's because this is going to be a geometry question. We can still help you out. It's got a diameter of 3 inches. I'm going to pause right there, and I'm going to draw a picture. Okay? So I've got a cup. Beautiful. Now, when it says a right circular cylinder, it just means a tube, a cylinder. Okay? And it already told me the diameter all the way across here is 3 inches. Okay, so far so good. Then it says he pours milk from a gallon jug into each glass until it's full. If the height of the milk in each glass is about 6 inches, what is the largest number of full milk glasses that he can pour from 1 gallon of milk? Okay, so then I don't know if it's saying that he's filling them all the way up. Let's just say, for lack of a better term, it's saying he's filling it all the way up. We know that that is 6 inches. Okay, so I've got a glass that's got a diameter of 3 inches and a height of 6 inches, and he's saying, how many full glasses can I get out of a gallon of milk? And then he says that there are 231 cubic inches in 1 gallon. I don't know why I'm using he. She says. This problem says. Okay, so you're trying to figure out what's the volume of this, basically. So I've got 231 cubic inches inside a gallon of milk, and I'm pouring that into this, okay? Now, don't forget, at the very beginning of the packet and your booklet, it gave you all of these things. This is where they come in handy. Look at right here. That's a cylinder. volume of a cylinder is equal to pi r squared times height. So I'm going to come back over here. The volume of this cylinder is equal to pi r squared times height. Don't forget r is only half of the circle. If the diameter is 3 inches, r is 1.5 inches. Okay? So r squared times height, if you punch it in your calculator, you're going to get about 42.4, something like that. Okay, that number should be good enough. All right, so if each glass gets about 42.4 cubic inches, how many times can we pour 42.4 cubic inches out of 231? So I'm going to take 231 and I'm going to divide by that 42.4, because every time you pour a glass, you take out 42.4. And you're going to get something that's approximately 5.5. Okay? Now you've got to come back here and think. You probably automatically could have taken off 2, maybe even 4, because you're pouring a gallon of milk here. You're trying to figure out how many glasses of milk are in a gallon. It's definitely more than 2, probably more than 4. So we're looking at 5 or 6. Do we round up or do we round down? Now, if I go back, it says largest number of full milk glasses. Can I get 5 full milk glasses? For sure. But can I get a 6th full milk glass? And you should say no, because it only has enough for 5.5. So the answer should be C, 5. All right, look at number 19. This is an example where they take something simple and they make it complicated. Just for a second, it says, well, if 3p minus 2 is greater than or equal to 1, what is the least possible value of 3p plus 2? Okay, I'm going to ignore the 3p plus 2 for a hot second. If they had just said 3p minus 2 greater than or equal to 1, and they had said solve, I bet almost all of you would get it right. You would add 2 to get 3p greater than or equal to 3, and then you would divide by 3. So then you would say p is greater than or equal to 1. Okay, now, that right there is not the answer. Because they didn't just ask what's the answer to this. They said what is the least possible value of 3p plus 2. Well, let me ask a different question. Knowing this answer right here, what is the least possible value? Let's write it. Least possible value of p. Well, if p is guaranteed to be greater than or equal to 1, the least possible value of p is 1. P equals 1. Because it's definitely not less than 1. It's greater than or equal to 1. So if I wanted to find the least possible value of 3p plus 2, I'm going to plug in the smallest p. So I took this p equals 1 and I plugged it in. Smallest p is going to give me the smallest value here. 3 times 1 is 3. 3 plus 2 is 5. That is answer A. Now, the sucky part about this question is a lot of people will see this, stop reading right there. Sorry, they'll see the 3p minus 2 greater than or equal to 1. They'll say, yeah, I know how to do that. They will solve it. They'll get p greater than or equal to 1. They'll see a 1 on there. They'll punch that in, whatever, fill in the bubble, and move on. They take something simple, make it complicated by throwing in this little piece here, because now you need to use the logic. Well, if I want this to be as small as possible, I need to plug in the smallest p that I can use. Well, p has to be greater than or equal to 1, so I'm going to plug in 1. Done. All right, number 20. A lot of words, but actually this should be one of those quick and easy things. All right, the mass of living organisms in a lake is defined by the biomass of the lake, or defined to be the biomass of the lake, whatever. If the biomass in a lake doubles each year, those 3 words right now, doubles each year, that should tell me almost everything I need to know. Doubles each year. What kind of line is that? Just keep that in mind. All right, which of the following graphs could model the biomass in the lake function of time? Notice in each graph below, O represents 0, 0. It's kind of irrelevant information. So now you're looking at like a line, stairs, exponential, or flat line. So if it doubles each year, which one of these things are we talking about? I'm hoping that you're saying doubles each year. That is exponential. Doubles each year. If it starts off at 1, next year it's 2, next year it's 4, 8, 16, 32, so on and so forth. It's actually going to be a curve going upwards. This one doesn't even make sense at all. Stairs, I don't get that, okay? But doubling is not going to be linear. It's not going to go up at the same rate. And this graph here actually says it's not going up at all. It's staying the same. So if you understand exponential stuff, then this should be one of those quick and easy questions. Doubles each year, that's exponential. Answer C, move on. Okay. Let's look at 21 and 22. Okay, so we're looking right here. Looks like we have a bar graph that shows the renewable energy consumption in quadrillions of British thermal units, BTUs, United States, okay, by energy source. And it looks like we're looking at 2 different years. We are looking at 2000 and 2010. You can see that 2000 is the darker bars, 2010 is the lighter bars, okay? Now we're going to use that information to answer question 21. In a scatter plot of this data, where renewable energy consumption in the year 2000 is plotted along the x-axis, and then 2010 is plotted along the y-axis. Okay, pause before I go any further. Scatter plot's just a graph, right? So it says 2000, so all of the information for the year 2000 is on the x-axis. All of the information for 2010 is on the y-axis, okay? And it says for how many data points would be above the line y equals x? Tricky question. First off, you need to know the line y equals x is going to look like this, okay? And then if I were to take these 1, 2, 3, 4, 5, if I were to take these 5 things and I were to graph them, for instance, this right here would be, let's see, year 2000, so this is my x value, 0.25, and then 2010 is my y value, 1.6, something like that. If you wanted to, you could make a rough graph and you could sketch them all. So 0.25, 1.6 would be over here. Hey, that is a point that's above the line y equals x. Now, here's a quicker way of realizing that. That means I've got more y's than x's, for lack of a better term, meaning the y value is bigger than the x value. So every time the y value is bigger than the x value, I'm going to be above this line y equals x. Hey, that should make it easier. That means all I have to do is I have to come find every single time where the y value, aka 2010, is bigger than the x value. So I need to find places where the light bar is taller. All right, check, taller, check, taller. Well, this one doesn't work because the dark bar is taller. Check, taller. This one doesn't work. That means there would be 3 different points. 3 different points that would actually fall above that line y equals x. And I'm done. Helpful hint there, draw a picture. All right, and we come to number 22. Of the following, which best approximates the percentage decrease in consumption of wood power from 2000 to 2010? Okay, so wood power. So I'm going to go back here, and I'm specifically going to look at wood. Wood power. That's this one all the way at the end here. There we go. So I'm ignoring everything except for this. Now notice, in 2000, it was higher than 2010. So notice the problem asked, what is the percent decrease? Well, before we talk about percent decrease, let's just figure out how much it decreased. So it looks like in 2000, it was at, what does that look like? 2.25? Okay. And then in 2010, it went all the way down to 2. So that means from 2000 to 2010, it went down 0.25 because it went from 2.25 to 2. So that's how far it went down. Okay, let's keep that in mind, and I want to go back to question number 22. So we went from 2.25 all the way to 2. That means we went down 0.25. Now, if I wanted to find a percentage decrease, I would say 0.25 divided by the whole, because this is how much it went down, and I want to figure out what is that as a percentage here. So then you would go in your calculator and punch in 0.25 divided by 2.25, and you get 0.111111111111111, yada yada yada, going on and on and on forever and ever until we all die. Then you've got to convert that into a percentage. This is 11.1%. Let's round it. If we look at our answers, realize the only one that's anywhere close, answer B, 11%. Done. Okay, kind of a tricky question, but again, SAT is full of tricky questions. All right, last one. 23, you've got two tables. Now, these are weird. They're frequency tables. We don't use these very often. If I were to write this out just to show you, it's talking about temperatures in two different cities. So I had 80 3 different times. Then I had 79 14 different times. And then I had 78 2 different times. Oops, 78. I had 77 one time and 76 one time. Okay, that's what this means. That's what a frequency table is. Same thing down here. Okay, I had 86 times. Okay, I had 79 3 times. I had 78 twice. I had 77 4 times. And then I had 76 6 times. Okay, so you get the general idea. So instead of writing out all these numbers, they just say, 80, that's gonna happen 3 times. 79 is gonna happen 14 times. Whatever. Okay. So which of the following is true about the data shown for these 21 days? Now, every single one of these answers talks about standard deviation. Okay, now here's the second part. Standard deviation does not come up on the SAT very often. It's a statistics problem. If you go into AP Stats, you will figure out how to specifically calculate standard deviation. You do not need to know how to actually calculate the standard deviation here. But to answer this problem, you do need to know what standard deviation is. Basically, standard deviation talks about how far your data points are away from the average. So if I were to take the average temperature and then I were to look at all of the numbers, how far are they away from the average temperature? Okay. Now, I am not by any means going to go through and actually find the average here. I've got a crap ton of numbers I'd have to add and divide. No. Some people will do that and they'll waste a bunch of time. No, instead, I'm just going to look at the spread here. Okay. Let me give you some. Oh, okay. Well, if I look at this first one, it looks like a lot of the data points are right here. Okay, 14 of the data points were at 79 degrees. Okay? So the average is probably going to be somewhere around 78, 79 degrees, right? Okay, and most of the data points are near the average. That means my standard deviation is very small. Small standard deviation. A different way of saying it is my spread is very small. Like these numbers aren't spread apart. I don't have a ton of high numbers and a ton of low numbers. Like most of them are in the middle. Versus here, look at, I've got 6 at the top, 6 at the bottom. It's kind of evenly spread out. So that means I have a high standard deviation. Notice I haven't done anything in terms of calculating. This is more of just a guess, and that's okay. So now it basically says the standard deviation of temperatures in city A is bigger, city B is bigger, they're the same, or it can't be calculated. Here's a quick tip. You almost never have two standard deviations that are exactly the same. pretty much the only time you'll have two standard deviations that are exactly the same is if you're looking at two data sets that are exactly the same. But other than that, no. Now, also, I have all of my numbers here, so I have everything I need to calculate standard deviation, so those two tend to be trick answers. Saying, oh, they're the same, or you can't calculate it. Usually, if you're looking at two different data sets, one is higher than the other. Okay? And now, since we said city A has a small standard deviation and city B has a large standard deviation or a high standard deviation, that means that the answer here would be B. That says the standard deviation of temperatures in city B is larger, and that just talks about their spread. All right, some tough questions there. On Wednesday, we will go through 24 through 30, and then we will move on next week. All right, miss y'all.